Hello everybody. For quite a long time I was thinking about tutorial about coroutines, and coroutines, basically the simplest explanation about coroutines, it's threads without threads. So you have threads, but switching between threads happening exactly in specified in your program time. And the advantage of coroutines, first, it's switching between routines, like let's say threads. In Windows they call fiber, and Linux in Linux there is some other POSIX mechanisms to do these things. So switching are quite fast because program do not need to do round trip to kernel space and back. And in our advantage of threads, it's you do not need to worry about synchronization. You do not need to worry about mutexes, because you know exactly when switching from one, let's call it thread 1 routine to another routine, happening exactly in position where you want to do. So I want to make some sort of library, some sort of graphic library for young people, for kids, to be able to program in C++ very easy, like using very simple concepts, but having quite interesting and nice results. So I want to implement turtle graphics using coroutines. So let's start. So I'm opening my text editor, and I am using Emacs, so adjusting sizes for recording screen like this. So now let's create the directory turtle graphics, and what I want to have, basically I want to do like include turtle.hpp, and here int main, and I just want to do like forward 10, left 90, forward 10, left 90, like this. So let's do not 10 but 200. So, and we should get square, but of course it's not going to work. Let's just do normal build, because I need to have turtle. So for turtle, here I will have functions forward int. Do I need to have int? Let's have float, right? Forward float, left. That's it for now. So it's going to be just proof of concept. Turtle.cpp, hpp. So I will have all of these things here. So now I can compile it, and here I will have some object which I will instantiate also. So let's call it turtle, and inside I will just have some global object, public turtle instance. So it's a static instance, and turtle instance will have static, and it will return it back. And here inside I will have turtle instance forward like this, and it's going to be for left, right, and backward. And class turtle will have internal parameters. It's going to be x, y, and direction where turtle is pointing, and implementing always forward. So basically I'm going to copy all these things here and implement it here. Let's move it down, right? For the instance I will move down also. So I need to implement these things. Okay, so for forward, actually it's value, right? Value, value, value. So, and what I want to do here, I want to have also animation, because for young person it's going to be more interesting to look how turtle doing all these commands slowly, because like modern computers are so fast, so there is no joy observing how your algorithm is working. So I want to do animation, and this is the beauty of coroutines, because I can encapsulate animation here and not mess around with state machine, or like if I would like to make it with threads, messing around with synchronizations like mutexes and all these kind of things. So I can just do simple thing here. So first of all, I need to figure out how much I want to move my object, right? So it's going to be calculating dx, and dx it's basically cosine of direction, and direction is in degrees, and we want direction in radians. So to convert it to radians, I need to divide it by 180 and multiply by pi. And pi actually in my compiler is already defined, but to make it work for all compilers, I will define it here. So const auto pi equals 3. I think it's good enough precision. And also I need to include math, cmath to be precise. So dx is like this, dy is sine direction multiplied by pi divided by 180 degrees. And now final destination of x and y is going to be new x is x plus dx multiplied by value, new y is y plus dy multiplied by value. And then I will move x and y till it's become greater new x or new y. So while, so what I need to do, while new x minus x greater 0, right? If dx is positive, right? So what I need to do, I need to multiply by dx. So greater 0 and uy plus minus y multiply by dy greater 0. So let's see, if dx is 0, yeah, so we need to do greater or equal 0. So if dx is 0, it's going to be always 0, but yeah, so I think we're good. One thing, so if value is 0, right, if value is 0, dx and dy are going to be 0. Oh yeah, so we kind of in trouble, because it will be always equal to 0 and equal to 0. So I can just make small if value equal 0 return. That's it, right? So now we should be good. And here I want to do like x plus equal dx, y plus equal dy. That's it. And here I'm going to do x equals new x, y equals new y. And here what I will do, I will switch from this routine to another, and I will do like yield here, just, and that's it. I think we're good. And what else I want to do, I want to do like move, and I want to do like this, and all this thing I'm going to implement and move. Void total move float x, float y, new x, new y. That's it. So just making code shorter, and actually this thing also I can do if wait. Yeah, I need to calculate dx and dy. I can calculate it here, right? Again. So auto dx equals this guy, and dy is, yeah, it's kind of suboptimal. Wait, I don't need move. So let me return everything back. So the new x equals this thing, the new y equals this thing. Yeah, so I don't need move. And yeah, let's do this thing again. And for backward, I just do for forward negative value. So left is simple. To new direction equals value, and here actually I have to draw things, right? So let's do draw x and y, x plus dx, y plus dy. Yeah, we can overshoot by 1 pixel, but it's 1 pixel, so we would not notice it, so it's fine. Yeah, and here we definitely overshoot, so we good. So we need, and we do not need yield, so we can do yield inside draw. Okay, so here new direction, we would need yield here. So and what we do while wait, new direction equals plus value. So we are turning left, and left actually it's plus value if I am not mistaken, but we have different coordinate system. So our coordinate system is x moving this direction and y moving this direction. So and if I want to turn left, I need to turn this way, so it means I need to do negative value. And then, but the problem is value might be, yeah, same trick, multiply by value. So value is, let's assume value is positive, and while new direction minus direction greater than 0 and plus equal just by 1 degree. So we're going to rotate by 1 degree, yield, and here we need to multiply by value. So if value is negative, yeah, so, and here direction equals new direction, and right is going to be left negative value. That's it. We implemented everything on the side of main function, and here's it. I will have yield and void draw float x1 y1 float x2 float y2. So one side is implemented, so I need to implement yield and draw. So let me try to figure out how to do this thing. So I'm going to use boost coroutines. I already practiced a little bit about this thing, but it was long time ago, so I do not remember. So let me refresh my things. So what I'm going to do, I'm going to use boost coroutines, and to use boost coroutines I need to include boost this thing. Yeah, good, it's compiling, and let's see, does it do good? Yeah, it does do correct include. So you can see it's need to use boost coroutine, boost context, and boost system. So it did to add everything of this thing. Pthread, we do not need pthreads, we are not using threads, which is awesome. So we did include this thing. Next thing what we need to do, we need to have push type or pull type. So I think on this side I will have push object, and basically it's a sync. So we'll have sync, and sync basically functor. So I can sync some data inside here, and for yield I need nothing, and sync for draw I need to sync x1, y1, x2, y2, and sync are going to be let's type div, and here can I have multiple things? Float, 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 float. Just wondering. Should be one. Unfortunately it should be one, so let's do tuple, tuple. Sync was not declared in this scope, yeah. So, and I'm going to declare sync here, and here td make, let's just push all zeros here, 0f. Oh, it's complaints for this one. Okay, so what what's bad? Not much for call to coroutines, float, std make tuple, float. So should be good. Should I include tuple? Didn't help. Sync coroutine sync. It's push type. Yeah, now I need to have what? Because the definition would be right, because we need to initialize sync somehow. Okay, so turtle. So here's the turtle, and I need to sync, and sync is going to be initialized by, this might be lambda, but I can have my function turtle. Let me call my function from inside lambda. So there is a lambda, it will take capture this, and it's a pull type, and pull type something. So sync, what we have sync, and so sync with dropping thing, and this guy is, I don't know, it's a drain. No, so for sync with pushing, to sync with pushing, and we're pulling from, I forgot. Yeah, it's a p. So inside p, and here I will just call loop, and for loop I will send p, and that's it. So here's it. We will have void loop, and for loop we will pull type p. So we have loop here, and we will pull things from loop. But first, yeah, I think I can auto IP, and I can just print out things for now. Get 0 from I, so it's going to be X, x1 0 1 2 3. Yeah, it's simple like this. So basically my demonstration for coroutine done here, so I can just run it and you will see results of things happening here. So yeah, I need to put spaces, but basically 0 0. Yeah, I need to put spaces. Yeah, and you can see how coordinates are changing. 1 2 3 4 5 till 100, and then what's going on? Oh right, till 100, and then still going till 200. All right, till 200, and then these coordinates start moving. So I was turning left, right? Yeah, so I turned left. So I'm going to use my turtle in 720p resolution, so like x is going to be 1280 divided by 2 and y is going to be 720 divided by 2, and direction actually is going to be negative 90 degree, so turtle initially will point up. So this is basically tutorial is done about coroutines, and now I'm going to do just implementing SDL part of turtle graphics. So here is a turtle in constructor. I will initialize, just wondering, would be able to get here? Yeah, I will get here, right? I will get here, and then it will, right, so this part is main part, right, and loop part is like a loop part. Okay, so, and because we do not need to worry about, yeah, I think we still should worry because of stack. So yeah, let's do all initialization and everything for SDL here, and we just go and open any SDL tutorial. I'll open my Tetris probably tutorial. So yeah, so here is it. I did open on the side my Tetris tutorial, and this side is going to be class definition, and here is it. I will do implementation, and actually yeah, I can implement everything here. So let me include SDL, SDL2, SDL, stage, and so I need SDL window, SDL window, and renderer, and that's it. Now I need to initialize SDL, and here I will throw exception. Oops. SDL init. Oh, let me just copy paste all these things. I will not print error for now. Create window and 720. So 1280 by 720. SDL window borderless window renderer, and also I will set window position. So I pre-calculated it billion years ago, 26. So this is my recording video. So I forgot % here. Let me keep compilation window here. Okay, and at the very end I need to do destruction. So in destruction SDL destroy SDL window SDL quit. So here we will have SDL loop, and inside the SDL loop I will have SDL event E Let me see, would it work at least here? So I should see some blip. Yeah, I did see blip. Probably you did see blip. So HDL pull event. I think I need HDL pump event probably. So pull event is blocking. No, pull event actually not blocking. Okay, so we good. So we do pull event here. HDL event E while HDL pull event E. So we do things, and here basically we case HDL quit if E dot type equals done equals true. Okay. While not done. So another thing, I need to figure out how to pull things. So P basically iterator and just doing plus P. Auto iter equals P plus iter while done, while not done, and iter not equal and P. std begin P. Interesting. Why does not work? Let's see documentation about pull type. Pull type. So I can reuse range iterator, right? Pull type. Where is the documentation? Push type. Pull type. In get. So I can use get while np auto I equals p get. And here I need to do SDL renderer. Yep. SDL render present renderer, right? Render, SDL render present. Yeah, now it's way slower. It looks like it's stuck. It's not ending it. If not done, and p get probably I need to do some sort of advance, and I did not do this thing. Let's see. Yeah, to do advance I need to do this thing. Yeah, now we're good. So next thing, I want to make the sort of texture, right? Or I can just redraw every time. Yeah, for now let's keep it simple. I'll have vector of these things and I will just draw all these things in the loop. Okay, let's keep it simple. So std vector. So we have tuple, right? Std tuple float float drawing, and I'll do drawing push back tt make tuple. Oh wait, I don't need to do just I, right? Okay, and then I just need to draw, and to draw I will do clear first, STL set there, draw color there. So I want to have black. Oh no, I want to have white. STL there, clear, and then for I will iterate through all drawing. Let's have I again. Let's simplify this thing. Can I do it like this? No, I cannot. Okay, it's fine. So I can do get and then do p. So auto const auto I out of drawing, and then just draw lines and draw set render draw color. So now I will have black color, and how to draw by category, draw line, SDL renderer draw line, std get 0 1 2 3 1 2 3. Let's double check. Yep, looks good. I think we're done. Isn't it awesome? I would like to have some sort of pause, and for pause I'll have just in our loop here, yep, until I close it, and I can close it, and that's it, we're done, and says process exited normally. Cool. Also I can make it slower. Let's make it slower, 10 times slower. We can make it 10 times slower here, and yeah, let's keep it like this. So also I can draw a circle, so let's, and we can see like this program is very simple and it's amazingly working, right? So let's draw a circle. Int I equals 0, I less 360 plus plus I, and here I will do forward 1 and left 1. Like here's it, we can draw a circle. We can make circle bigger, and you see I can move the window like everything is working, it's not blocking. So I can make circle bigger, just doing smaller turns, like let's do, and you can see it will draw bigger circle. And you know, while it's drawing I can still stop this thing and it will stop normally without any issues. It's not blocked. This is the beauty of coroutines. So that's it. I don't know what else I can show you. I can do this thing, right? Float a0 a, and here's it a plus plus, and actually I can do it here while infinite loop. I don't think I can do infinite loop, it will stuck, right? But yeah, it will stuck, but it's fine. Yeah, so we can draw these cute things. Yeah, it did break. Yeah, it did break here. Actually I can have here some sort of like terminated equals true. And you know, I think I can do like there is a sync, right? Sync. So I can check sync if sync. Yeah, so now we should be good. And also I can, and yeah, so it will now it will just stuck. Like if I'll try to close this window, it will just freeze here. Yeah. Okay, let's do smaller turns. Compilation is insanely fast. Yeah, let's do smaller, I don't know, like this, and we can start from negative value like 90 degree. Yeah, now it's stacking. Yeah, 90 degree is not good idea. Let's have 1 degree. Yay. Anyways, let me publish this code on repository on GitHub. Let me stop this thing. You know, I can have always, yeah, I can just throw exception here. Let me do this thing, right? So if sync else throw std runtime error sync. So here I can have try catch. Yeah, like this. And stream. Oh, now it's a little bit slower compilation. Yeah, so it's drawing, and I just close the window, and it's complaint. And actually, I can print it out here. Error. Yeah, so we made it a bit better. So, and then I get bored, I just do like close, and that's it. And it's print error sync. So let me post it on Git. So let's do GitHub. Sign in. So new repository, turtle graphics, coroutine example on turtle graphics. Public repository, create repository. So cd turtle graphics, git init, and then git. Now I need to add this file, and this file. That's it. Commit, initial commit, then commit, and I need to add remote and do push origin master. So remote push origin master, and it should be here. That's it. So it's here. This is address. Thank you for watching, and hopefully see you next time. Bye.